think this is a good problem if there aren't any questions. So this is in the notebook 0. And basically, I just want you to find the difference between the sum of the squares and the square of the sum for the first 100 natural numbers. So 1 through 100. So there's kind of two solutions I would think about. You can use 2 list comprehensions, right? So 2 list comprehensions. And both of them would kind of range. Oh, sorry, it should be 101. So the first would be I times I square. So here we're just computing them separately. So the sum of the squares minus the sum squared. Or you could oops. Should be a minus sign. Or if for some reason you wanted to do it this way, actually, no, that's the only easy solution I can think of. You can use the formula for the sum of the first n integers, n times n minus 1 over 2. And then just a word on like computational efficiency. Python is slow if you want to do a lot of numerical calculations. That's kind of why NumPy and PyTorch and all these frameworks are developed. Those frameworks are actually written in C. So it takes your data from Python and uses a C code to operate on that data. So you'll often get significant speed ups if you use the NumPy versions of all of these functions and data structures. So for example, dot array. So if we just time, if we time how long it takes to perform this operation, and then okay, so this is actually slower because I can do this. So if you don't have to make this array, it will be faster than this. Or if you, for example, have, let's say, 10,000 or 100,000. It's still faster. Yeah, I think you need to make this so that this part is outside. A is that sum of I in A. Right, so 205 microseconds versus 20 milliseconds, like factor of like 10, 100, factor of 100 faster. And that's actually why like GPUs are so important for machine learning. Your neural networks are matrix multiplications, and that's essentially what GPUs were designed for. And you can often get a factor of 10 to 100 faster on a GPU than on CPU. Okay. So this next exercise just helps you practice using functions and conditional statements. Yeah, this is a famous unsolved problem in math called the Collatz problem or Collatz conjecture. And it's if you repeatedly apply this rule to a number, well, you always get 1. So far, it's known up to like 10 to some large number that this holds, but it's unknown if it holds in general. This is just how would you evaluate if a specific number satisfies this property. So I'm saying that if the number is even, then we're returning n over 2. Else we're returning 3 times n plus 1. And here, computing the length of the Collatz sequence for one of these. So we'll say every time we do this, we're going to call Collatz, and we're going to add 1 to the total length. Right, so this keeps executing until n equals 1. And then here, we'll just use a list comprehension to calculate the lengths for everything up to 1 million. This might take a while. Also, these underscores, you can put them anywhere you want in your numbers. They're more for readability than for like any other purpose.